All right, students, today we're going to solve a circumcenter. Now remember, a circumcenter is created through perpendicular bisectors. So we're going to create those on this figure right now. So we have perpendicular bisectors. Where those perpendicular bisectors meet, so here's a perpendicular bisector, FD is a perpendicular bisector, and GD is a perpendicular bisector. Where those perpendicular bisectors meet is called the circumcenter. Now, the unique thing about a circumcenter is that the line from the circumcenter to the vertex is the same distance no matter where the circumcenter is in the triangle. So that's the pattern for circumcenters, is all of the circumcenter to vertex are congruent. In addition, all of our sides, so G is a midpoint because that's a perpendicular bisector. F is a midpoint because that's a perpendicular bisector. And CE, because that's a perpendicular bisector. All right. So what's interesting about circumcenters is that you have congruent triangles in here. And if you know where to look for these congruent triangles, it makes solving these triangles very easy. So here is one set of congruent triangles for a circumcenter. So I'm going to highlight this guy red. Then I'm going to highlight this set of triangles blue. Because again, these two are congruent triangles. And I'm going to highlight the third one green, because this is going to help us when we're solving these guys. All right. So now, the first thing that I want to do is look at my angles. So if I look at the red triangle, I have a red angle right here that is 41.7. So that means this guy is also 41.7 degrees. And because I know that the interior sum of a triangle is 180, I can find that second angle. Remember, my perpendicular bisectors are 90 degrees. So I can take 180 minus 90 minus 41.7, and that is going to give me 48.3. So here's 48.3 degrees. And remember, this guy is congruent to this guy here. So we got 48.3 degrees here as well. All right, I'm going to erase that because I don't have a lot of room here. And I'm going to do that for all my triangle angles. So I can take care of my angles first. So in my blue triangle, I have 26.3 here. So this guy up here is also 26.3 degrees. And then we know that our right angles are 90 degrees. So then I can take 180 minus 26.3 minus 90, and that is going to give us 63.7. So I've got 63.7 degrees here and 63.7 degrees here. I took care of the blue triangle. So then I'm going to take care of the green triangle angles. So again, I've got 22 degrees up at the top here. So that means I have 22 degrees at the bottom here. And again, I have a right angle here. So this guy is 90 degrees. So I can take 180 minus 90 minus 22. And that's going to give me 68 degrees. So this guy is 68 degrees, and this guy is 68 degrees. Because those two are congruent, as well as these guys. All right, so now I have all my angles done simply by using the interior sum of a triangle equals 180 degrees, and knowing my pattern that I have congruent triangles right here. So the angles are congruent, and then my interior angles up here are congruent. So this is a congruent triangle to this guy. All right, so now I'm going to use the Pythagorean theorem to solve for all my side lengths. So if I'm looking at, let's just start with the red triangle here. So if I look at this triangle, let's see, I need one that has two sides. Let's see where we go. All right, let's start with the green. So I'm looking for two side lengths, whether it's a hypotenuse or two legs. But my triangle right here in the green, I have two legs. So let's go ahead and start with that guy. So if I look at this, it looks like this. Here's my right angle. This guy is 12.5 and this one is 31. So that means my hypotenuse is x. Remember that this equation would be x squared is equal to 31 squared plus 12.5 squared. And to solve for this, I got to take the square root of both sides. So I have the square root of 31 squared plus 12.5 squared. So if I do that, put that in my calculator, I end up with 33.4. So this is my length right here. I've got 33.4. Now remember, this is my vertex to my circumference, and all three of these are congruent. So I'm going to change my color here. I'm going to change this to 33.4. This guy's also 33.4. And over here I've got 33.4. All three of these guys are congruent. Okay, so I'm going to erase so I can keep going here. So I'm going to, oops, I erased my degrees. I'll put that back. So this was 22 degrees. All right, so now remember, because this triangle, this green one here, is congruent to this triangle here, I know 31. This guy is also 31. I don't have to do any math to find that. And I already know the circumcenter to the vertex, so my green triangles are taken care of. Now let's look at my red triangles. I have a hypotenuse and I have a leg. So let's draw that triangle. So this guy looks like this. Oops, wrong color. Looks like this. And then I've got 33.4 as my hypotenuse and 22.3 as my leg. So now remember, again, I'm using the same equation. So I've got 33.4 squared is equal to x squared plus 22.3 squared. Well, I got to get rid of that 22.3, so I'm going to move it over. Move this up for right now. So I'm going to subtract 22.3 squared. So I'm going to have minus 22.3 squared. So I'm going to rewrite this. So I've got x squared is equal to 33.4 squared minus 22.3 squared. And again, I got to take the square root to get rid of that exponent, because remember, those two cancel each other out. So I've got x is equal to the square root of 33.4 squared minus 22.3 squared. And if I do that and put that in my calculator, I end up with 24.9. Now remember, these two red triangles, this one right here and this one right here, are congruent. So that means that 24.9 also goes here. All right, I'm going to erase all this again. And now go from my blue triangles. So, right off the bat, I have the 30. I can put 30 up here. And then let's draw my triangle. So I have the 33.4. That's the hypotenuse. I have 30 for the base, and I'm looking for a leg. So again, I'm going to take 33.4 squared is equal to x squared plus 30 squared. I'm going to move that 30 across. So minus 30 squared. I'm going to equal to x squared. So I've got 33.4 squared minus 30 squared. And then to get rid of that square, I'm going to take the square root. So I end up with the square root of 33.4 squared minus 30 squared. And if I do that, I end up with 14.7. So that means this guy right here. Oops, that is not a good way to draw that. Let's try that again. So this guy here is going to be 14.7. And then I'm going to erase all this, get this out of the way so we can look at this. So now I have solved for all of the lengths and angles of this triangle. So again, kiddos, the pattern for the circumcenter is that it is created through the intersection of the perpendicular bisectors. The perpendicular bisectors give me congruent sides on the triangle because technically F, G, and E are the midpoints of these segments. So segment BG is congruent to segment GC. Then the circumcenter to the vertex of each one of these triangles is congruent in a circumcenter. So using those, I now have two congruent triangles. So you have to look for these congruent triangles. Once you find the congruent triangles, you can find the congruent angles. You can solve for the third one because one of them is 90 degrees. And then you're going to have side lengths. So either a hypotenuse and the legs, but you can use the Pythagorean theorem to solve for each triangle.